To solve the next part of the question, here we have the lift force on the plane acts perpendicular to both the plane and the wind and is given by this equation. L is equal to A V cross W. So be careful, this is not regular multiplication, this is cross product, also called the vector product. And it is given that the magnitude of L is equal to 88 and we are supposed to find the value of A. And this velocity and wind velocity is from the first part of the question. Now, since we are supposed to find the value of A, let's look at this equation. So let's rewrite L will be equal to A V cross W. And since it's given that the magnitude of L is 88, let's take mod on both sides of this equation. So we will get mod L on the left hand side and the entire thing on the right hand side will go under the modulus. Now mod L is equal to 88. Now A is a constant. We can take that out of the modulus sign and we get mod of V cross W. Let's make A as the subject since we are supposed to find A. And A is equal to 88 divided by mod V cross W. So all we need to do is find the magnitude of V cross W. So we have the V vector and the W vector. We find V cross W. To find the cross product or the vector product between two vectors, we employ this particular formula. So as you can see, A and B are two vectors and A cross B is given by this particular formula. So let's apply that. We have to find V cross W. So V is, let's write it down, -3, -12, and 4. And we are supposed to take the cross product with the W vector, which is 4. And K we had found out as -1/3 and 2. Let's solve the vector product using this particular formula. So let us write V cross W will be equal to, it is going to have three components, X, Y, and Z. For the X component, we'll write -12 multiplied by 2 minus 4 into -1/3. Let's simplify this before we move ahead. So we'll get -24 plus 4/3. That's the X component, which can be simplified further. For the Y component, we employ the same formula. So we'll write 4 into 4 minus -3 into 2, which we can simplify to 16 plus 6. And for the Z component, we'll write -3 into -1/3 minus 4 into -12. Let's simplify this. We'll get 1 plus 48. So the final answer of V cross W will be the X component will be simplified to -68/3. The Y component is 22 and the Z component is 49. So that's our V cross W. Going back to the question, we were supposed to find the value of A, which is 88 divided by the magnitude of V cross W. Since we have identified V cross W, we will apply the formula for the modulus. So the formula goes like square root of the X component squared plus the Y component squared plus the Z component squared. And if we simplify this, we will get approximately 48.69. That's the magnitude of V cross W. Going back, we were supposed to find the value of A, which is 88 divided by the magnitude which we just found out. So A will be equal to 88 divided by 48.69. And if we solve this, we will get the value of A as approximately equal to 1.51. And that's the answer. This is the kinematics question in which it's given that an alien is moving with a constant velocity to 5 minus 1 and at t is equal to 5, the position is given as 5 minus 3 and 7. We have to find the vector equation for the displacement in terms of time t. So let us revise the concept. So here we go. So observe, if you have an object which has an initial position vector A and it is moving with a velocity B, then after time t, the position vector is given by this formula, r is equal to A plus TB. A stands for the initial position vector, which is at t is equal to 0. And B stands for the velocity vector, which in this case is 2, 5, and -1. It is given that at time t is equal to 5, the position P is 5, -3, and 7. So if we put t is equal to 5 in this particular expression, the value of r will be 5, -3, and 7. So let's write it down. The equation is r is equal to a plus tb, a plus t, and b is the velocity vector, which in this question is 2, 5, and -1. Now, if we put the value of time as 5, r 5 minus 3 and 7. So let's put the values in. This will be equal to a plus 5 into 2, 5, and -1. Let's simplify this further. So we'll get 5 minus 3, 7 equals to a plus, then we multiply 5 with all the three components of this vector. So we'll get 10, 25, and -5. Let us make a as the subject. So we'll get 5 minus 3, 7 minus 10, 25, and -5, which can be simplified to write -5, -28, and 12. That is A. What does A stand for? That's the initial position vector, which means the position vector at t is equal to 0. Now, the question was, we have to find the vector equation in terms of time t. So, again, we use the same equation, r is equal to tb. So, let's write down r is equal to A, which we have just found out as -5, 28, and 12 plus t times the velocity vector, which is 2, 5, and -1. And this is the position vector of the alien after time t. In this question, it's mentioned the player's avatar is located at a particular point x. If the alien continues with the velocity given, verify that it will pass directly over point. In the previous part of the question, we had found out the vector equation of the line in which the alien is moving, so which looks like this. Now, the question is to verify whether the alien will pass directly above the avatar. So let's try to understand what does that even mean. So let's draw the coordinate system, the x, y, and z axis. So initially, let me locate the point x. So in the diagram, let me write x randomly. That is the position of the player's avatar. Now, since we need to verify whether the alien is passing above X or not, how do we do that? So we are going to use the reverse approach. So we assume that the alien is above the avatar. So above X, we will have the alien. Let's say A represents the alien and X is the player's avatar. Now, all you need to do is observe in this particular diagram, if alien is just above the avatar, what that means is the X and Y coordinates for both of them will be the same. It's only the Z coordinate which is changing. Let me repeat. If the alien is above the avatar, the X and Y coordinates are going to be the same for both alien as well as the avatar. It's only the Z coordinate which is changing. Now, back to this equation, which is the vector equation for the alien. Let's simplify. So the x component will become -5 plus 2t. The y component will be -28 plus 5t. And the z coordinate of the alien is 12 minus t. Now, we just said that since the alien was above avatar, this was the assumption which we are using. Assuming that is true, then the x and y coordinates for both the alien and avatar are the same. So what we'll do, look at the player's avatar location 11, 12, and -5. So we will write 11 and 12 as the x and y coordinate for the alien. Be careful, these coordinates are for the alien and 11, 12, and -5 are for the avatar. But what we'll do, we will equate the x coordinate to 11, the y coordinate to 12, but the z coordinate is different. That's what we had done in the assumption. If the alien is above the avatar, x and y coordinates will be the same. It's the z coordinate which is changing. Now we will try to solve this and then we check whether our assumption, which was the alien above avatar, whether that assumption was true or not. So let's solve. So if we equate the x components, so we'll get -5 plus 2t equals to 11. That's the x component equation. And for the y component, we'll write -28 plus 5t equals to 12. So from the first equation, if you solve for t, we will get t as 8. In the y equation, so -28 plus 5t is 12. If you simplify this, we also get t is equal to 8. So since we are getting the same value of time from both the equations, that means our assumption was true. And what was the assumption? The alien being above the avatar. And that is enough to verify that the alien is actually passing through the avatar. So let us revise, what did we do? Since we needed to verify whether the alien is passing over the avatar, we are using a reverse approach. The approach is, we assume first that the alien is above the avatar and then we try to prove that assumption correct. Now, since the alien and avatar, we have assumed they are directly above, so the x and y coordinate for the alien and avatar will be the same. And that's why we have written here 11 and 12, but the z coordinate will be different. And since we were able to find the exact same time from both these equations, that's enough to prove that our assumption was right. In the second part of the question, we have to find the vertical distance between the alien and the player's avatar. Vertical distance is nothing but the difference between the z coordinates. So let me write it down. For the second part, the vertical distance between the two particles will be equal to the difference in the z coordinates. So let's write down z1 minus z2. And since it is distance, we take the magnitude of that. So what is the z coordinate for the player's avatar? In the question, it is given as -5. So for z1, we will write as -5. Now z2 represents the z component of the alien. For the alien, the z component is this 12 minus t. And if you put t as equal to 8 in this, so 12 minus 8 will become 4. Hence, z2 is 4. So if you simplify this, we will get mod of -9, which is equal to +9, since we are finding the distance. Hence, the vertical distance between the alien and the avatar at that point is equal to 9 units.